All right, guys, good morning. So last lesson we started to look at equations with fractions. It's the kind of thing that for some of us takes more than a period, right? Like I said with the first example, very few people look at the first one and say, oh, that's great. I really get it now. I can do every single one. Some people can. But a lot of us, we just need more time. We need more exposure to this. So we're going to do another lesson today. We're going to see some with variables on both sides. We'll see a little distributive property too. But today's lesson is actually not going to, it's more of a reinforcement from yesterday's lesson. So for the first do now question here, which you guys are going to do, of course, the common denominator is going to be 10. So I'm going to multiply everything on both sides by 10, which is going to give me 40x divided by 10. It's going to give me 30x divided by 2. And then here it's going to give me 190. So 40x divided by 10 is 4x. 30x divided by 2 is 15x. So this one's nice and easy. All right, and for the second one, we would multiply everything by 6. You know what, I'm going to do method 2 here. Because for me, x divided by 3, if I need to make that a fraction with the denominator of 6, is easy. I multiply the numerator and denominator by 2. So x thirds is the same thing as saying 2x sixths. Okay, well that's not so bad. So I convert this into 2x sixths minus 5x sixths. Now when I do that, 2x minus 5x is negative 3x, so negative 3x sixths is equal to 6. Now negative 3x sixths, if I simplify that, is really just negative x halves. Now I'm not going to do it that way. I'll multiply by the reciprocal, which is negative 6 thirds, which also is negative 2. So a lot of different things we could do to simplify this. I'm going to try to keep it simple in the sense that, I think this will make the most sense to most of us, just seeing what the coefficients are. And then we get x is equal to negative 36 divided by 3, which is going to give us negative 12. And if we check it, we get negative 12 thirds is negative 4 plus 10 is equal to 6. So it certainly will check. So that was a little look at method 2. If you were doing method 1, you just multiply everything by 6, which would clear out the fractions, and it would actually be really easy. If you multiplied everything by 6, you're going to end up with 2x minus 5x equals 36, negative 3x equals 36, and x is negative 12. So that's what I'm sure most of you had. All right, so now when I do this lesson in class, my question is always, well, what's different about this one? And then someone raises their hand and says, well, we didn't see variables on both sides yesterday. Now, the procedure is not going to change. So if I'm using method 1, the denominators are the same, I would multiply everything by 5. But I always tend to do this one using method 2. And I always ask the question, why am I going to use method 2? And someone says, well, the denominators of the fractions are the same, so that actually would make it pretty easy. And I say, well, that's correct. So if I add negative 1/5 x on both sides, again, we eliminate terms by adding opposites on both sides, I get 10 equals 3/5 x minus 11. Now it's a two-step equation. I add 11. So I have 21 equals 3/5 x. I'll bring it up where I've got some more space over here. We know if we have this one-step equation with a fractional coefficient, we'll multiply both sides by the reciprocal. And that's going to give me x is equal to 35. And if I check it, 1/5 of 35 is going to be 7 plus 10. 4/5 of 35 is 28 minus 11. Now, obviously, this is not how we do the check. We would rewrite, substitute, and evaluate, right? We've done enough checks at this point to know that. I just wanted to kind of show you what it would look like after the first two steps. And again, could we have done method 1? Sure, you could have multiplied everything on both sides by 5. If you did that, if you multiplied everything on both sides by 5, you'd end up with x plus 50 equals 4x minus 55, which would give you 3x equals 105, divided by 3x is 35. So just in case you decided to do that using method 1, I want to let you know what it would look like. All right, I'm not going to really love method 2 here because the fractions have different denominators. Could you turn 2/3 a into 8/12 a and 1/4 a into 3/12 a? Of course you could do that. But I'm really going to prefer to multiply everything by the common denominator, which is 12. But it's got to be everything. Okay, as always. I mean, it's nothing new, but sometimes we just do the outside terms, we just do the variable terms. I have to multiply everything. So 12 times 2 is 24. 1 times 3 is 3. And then 12 times 3 is 36. So when we're multiplying the integers, I don't need the denominator of 1, right? I don't need to do 12 over 1 times 3 over 1 is 36 over 1. Just do 12 times 3. And that's what I've been doing. Now I need to do it here as well. That's going to give me 12 fourths. And of course, we're going to do 12 times 7, which is negative 84. All right, so 24 thirds is really 8a. 12 fourths is really 3a. So now it's a typical equation with variables on both sides, right? I want to eliminate my smallest variable term, so I'm going to add negative 3a on both sides. So that's 5a plus 36 equals negative 84. So that's 5a equals negative 120. Now I'm going to divide both sides by 5, and I get a is equal to negative 24. If I substitute to check, 2/3 of negative 24 is negative 16, plus 3 is negative 13 on the left. 1/4 of negative 24 is negative 6, minus 7 is negative 13 on the right, so it certainly will check. All right, and again, could you have used the other method? Yeah, you could have done 8/12 a minus 1/4 a minus 3/12 a is 5/12 a. So if you did it using method 2, what you're going to end up with is 5/12 a is equal to negative 10. Multiply both sides by 12/5, and you get a as negative 24. So just in case you wanted to look at the other method, that's what you'd get as your equation. All right, what are we going to do for this one? Well, for most of us, we're going to distribute. So I will show you another method to do it. I would much prefer, unless you really understand what we're doing here, that we're going to distribute. So I've got 2/5 x, and then 2/5 of 30 is 12. So that's my equation after I distribute. I'm going to add negative 20 on both sides. So I know that 2/5 x is equal to negative 32. And again, guys, we go back to multiplying by that reciprocal here. And that's going to be 5/2. That's going to give me x equals negative 80. And if I look at the check, negative 80 plus 30 is negative 50. 2/5 of negative 50 is negative 20. Now, there's always someone that wants to clear out that fraction, which I like the idea to do that. It's not for everyone. So I've got 2/5 times x plus 30. Right? So if you really want, and again, this is this is just like a little extra. You don't have to do this. If you want to get rid of that fraction right off the bat, you can multiply both sides by the reciprocal. And I don't really have a lot of space to show it on the other side, but I am going to multiply by 5/2 here. So 5/2 times 2/5 on this side is going to give us 1, which means we clear out that fraction. And then I have to do 5/2 of negative 20, which is negative 50, and then I can solve the equation. Right? And this is one of those things that once we see it, we say, wow, that's a little bit faster. Why don't you just teach it to us that way? Well, the problem is if I have other terms, it doesn't really work so well. In other words, if after the x plus 30, I had like minus 15 or plus 10 or something like that, well, then that 5/2 application, you'd have to multiply the other number by 5/2 also. And a lot of times we just forget those things. So if you want to, again, something else, you want to experiment with it, see, make sure you get your answer, go back and check it, see what works, see what doesn't work. So it's always going to work, but the problem is if this was, let's say, 30 plus, and then the rest of it, I'd have to multiply the 5/2 like I did, but I'd also have to multiply the 30 by the 5/2, and that's the part we forget about. So again, this is just a little extension over here if you want to think about doing something a little bit different. All right, guys, so this is your now try. So you're going to pause it now. And then when we come back, so here I'm just going to kind of show you very quickly because this should be an easy one. I'm going to use method 2 because the denominators are the same. So I'm going to add negative 1/8 x on both sides, which gives me 3 equals 5/8 x minus 7. I'll add 7 on both sides, which gives me 10 equals 5/8 x. I'll move it over here. Of course, I'll be multiplying by my reciprocal, which is 8/5. And that's going to give me x is equal to 16. And if I check it, 1/8 of 16 is 2 plus 3 is 5 on the left. 6/8 of 16 is 12 minus 7 is 5 on the right. All right, for the second one, definitely going to use method 1. So I'm multiplying everything on both sides by 10, right? That's the common denominator of 2 and 5. So that's going to give me 30x over 2. This is going to give me 40. This is going to give me 30x divided 5, and this is negative 90. Now when I simplify those fractions, 30x divided by 2 is 15x plus 40. 30x divided 5 is 6x minus 90. I need to move my variable term. So that's 9x plus 40 equals negative 90. Let's divide both sides. Let's move the 40, but I'm realizing that something looks a little bit off here. Let's see. Actually, what I'm realizing is I don't know where I got 30x from over here. Let's take this back a step, guys. I apologize for that. So when I multiply here by 10, I should have 10/5, which is going to be 2. So yeah, I can understand some of our confusion here. So let me go back and fix this. So this should be 2x. And now this is going to work out a lot cleaner, right? So I move my 2x. I get 13x plus 40 equals negative 90. I'm going to add negative 40 on both sides, which of course gives me 13x is equal to negative 130. After dividing by 13, I should get x is negative 10, which is, I'm hoping, what you guys got as well. And if I check it, 3/2 of negative 10 is negative 15, plus 4 is negative 11 on the left, and 1/5 of negative 10 is negative 2 minus 9 is negative 11 on the right. That's what your check should look like. All right, guys. So this is going to be, once again, your homework, okay? If you were in class, this would be our classwork. For those of us doing this remotely, of course, this will be your homework. It says use either method to solve and check. All right, so I would probably be using method 1 for all of them. Now, number 1's a little tricky because we have 3 different denominators. So I'm going to just tell you the common denominator for number 1 is 20, right? Because all 3 of those numbers are divisible by 20. But again, if you use something bigger like 40 or 100 or anything like that, it will work. Number 2, if you want to try method 2, you can, right? X divided by 3 is the same as 2x divided by 6. I personally would do method 1 for all of them. Number 3, if you want to use that little shortcut I told you before to multiply by 4/3 at the beginning, you can try it out. Just make sure your answer checks, but I would probably just distribute. And number 4 is similar to, I believe, the second one that we did here today. Your common denominator is 15. You can multiply that to clear the fractions.